It's a pleasant day again. This is the continuation of our previous video. Before we proceed, let us have a small recap of what we have discussed previously. We have discussed the difference between scalar and vector quantities. When we add scalar quantities, let's say 30 kilometers plus 50 kilometers, then we just use simple addition operation by saying 80 kilometers. But when we say vector quantities, if we say let us add 30 kilometers east, this is a vector quantity, plus 50 kilometers west. When we add vector quantities, we cannot sum them just like this. We cannot say 80 kilometer and just add W west and just add east here. This is not allowable. We cannot do this. So in scalar quantity, we can just do simple addition. In vector quantity, we cannot do it. So therefore, our topic today is how do we add vectors? Vectors. So this is the question. So let us move to vector quantities. Now, there are so many ways, so many methods to add vectors. One of the things that I wanted to present here, this is the most important one, is what we so-called component method. Component method. This is another technique. There are so many techniques or so many ways to add vectors. This is one method. Another method is the polygon method. And polygon method is one of the most exciting method here because you're going to use objects and polygons and so much and so forth. Last but not the least, we have the parallelogram method, which is just a higher variation of parallelogram method, which is a higher variation of polygon method. The way you solve this parallelogram is the same as how you solve polygon method. So let us go first with the component method. So let us discuss first component method. Now let us have this system of forces. We have three forces. What type of forces are these? These are concurrent forces because they have a common point of application. They have the same point of application. So we can put common point of application here. These are concurrent forces. Now let us give magnitude to this one. Let's say this force is, let us say, approximately 60 Newton. Let's say this is 50 Newton, a little bit smaller than this one. Let's say this is 25 Newton force. So we have three forces. Now, if I say I wanted to add all of this, you can see vectors, they are scattered. They have different directions, although they have magnitude. You might say, if I ask you, what is the sum of these forces? You might be tempted to say that I will just add all of them, 50 plus 60 plus 25, which is 110, 135. You might be tempted to say this one, but we cannot do this one. We cannot just simply add them because this has different direction. This is directing towards top right. This one is top left direction. This is pointing downwards, so we cannot sum them in a simple addition. So before we proceed to the component method, how do we sum? Our main objective, you must understand that our main objective is to sum forces or to sum vectors. These forces are vector quantities. How do we sum these three forces? This is the main objective. Now, before we proceed to the component method, let us first define direction of these forces. Now, of course, we know the direction it is directing towards this one. This one is directing towards this one, and this is directing towards downward. Now we wanted to specify the exact direction. To determine or to define the direction, we need to use reference. And this is my advice. It is much more better to make the reference with respect to horizontal axis. So I'm just gonna draw a horizontal axis here. As you can see, I don't know if you can see it. Probably I'm just going to use red. Red color is much more better. I will use a horizontal axis or an x-axis. I think it is clear. You can see this is the reference line. Now, for me to be able to describe the direction of 60 Newton, I would say that, let's use the green one. I would say that 60 Newton is with respect to the horizontal angle or horizontal axis at a 30 degrees. Okay, we can also use the angle between 50 and the horizontal as a direction. Let's say this is 65 degrees. And of course, this is acting vertically downward, so the angle between this 25 with respect to the horizontal is 90 degrees. They are perpendicular, so it doesn't need any kind of angle. Okay, we just assume that this is 90 degrees. Now we have a complete definition or description of the force. If we try to magnify, let's say I'm going to magnify the value of 60. Let's magnify the value of 60. Let's just exaggerate the value of 60, and it has an angle with respect to horizontal. We have an angle, how much? 30 degrees. 30 degrees. So our force is what? 60 Newton. So we have the 60 Newton, which is a direction with respect to horizontal axis of 30 degrees. So this is the exact description of the force. Now, what do you mean by component method? If this 60 is going to be represented by two forces, or let us going to break this 60 into two forces, namely components, so we can do that. We can do it by using this one. I'll just try to do it, okay? So let's say this one and this one. Okay, so what we have just did here is that we break the 60 Newton into two components, or we just represent 60 Newton into two components. The name of the first component is called Fx, which is a force that is parallel with the x-axis, and the other one is Fy, which is a force that is parallel with respect to y-axis, parallel to the y-axis rather. So how do we understand? The problem, or initially our problem is 60 Newton, but we just made it three forces. It seems as if I just made the problem a little bit complicated. Instead of having to deal with the 60 Newton, one force, I just made it three forces. Now this is how we are going to understand this one. This is how we are going to understand. Suppose that there is a president. Suppose this is a president. This is our president. Okay. Now there is a meeting that the president needs to attend. Let's say this is a meeting. This is a meeting place. There is a door here. This is a meeting place. Now the president is about to attend the meeting, but suddenly there was an emergency. emergency. There was an urgent emergency that happened, therefore he could not attend the meeting. So instead of him attending the meeting, he delegates two of his vice president. So this is the vice president 1 and this is the vice president 2. He delegates them. In other words, the role of these two vice presidents, their role is to represent the president, or on behalf of the president, they are going to attend the meeting. Okay, now, the question is, this is the question, you have to understand this properly, and you have also to listen. If the president is present in the meeting, let's say the president, he came to the meeting, now the president is present in the meeting, is it necessary for these two vice presidents to represent the president? Now the president is present in the meeting together with the two vice presidents. Is it necessary for the two vice presidents to represent the president? Did you understand the meaning, the question? Of course not. When the president is present with the two vice presidents or the representatives, the function of these two are no more. They will have no function whatsoever because the president is present. In other words, if the president is present, the two representatives could not represent him. If the president, let's say if the president is not in the meeting, then that's the time that the two can represent him in the meeting. So what do we conclude? If the president and the two representatives are present in one single setting, if they are present in one single setting, then there is only one who can represent. If the president is present, then the two could not represent him. If the president is absent, then the two can represent him. And I guess you have understand the logic. And the logic here is like this. If we use the 60 Newton, we cannot use the Fx and the Fy. Okay? I think it is clear. Now, if I use Fx and Fy, these are the representative of 60. The president now is the 60 Newton. The Fx and the Fy are the representatives. If I use the representatives, Fx and Fy, we cannot use the president or the 60. And I think I made it clear. Now, how do we get the value of the Fx or the force with respect to x and the force with respect to y? These Fy and Fx are representatives of the force 60. Okay? It is just a representative. If I use them, then we cannot use 60. If I do not use them, then we can use 60. Now, how do we solve it? This is a very simple, basic trigonometric function. That's why I told you that you should get the direction or the angle with respect to the horizontal so that we could immediately use this. We could use trigonometric function, which means that this is a right triangle and this is the 90 degree. If this is the hypotenuse or the magnitude or the length of the hypotenuse is 60, the magnitude, we could get the adjacent. This is called the adjacent because it is adjacent to the angle. And this is called opposite because it is opposite with respect to the angle 30. Okay? Now, the partner of adjacent, Fx is an adjacent, this horizontal component. Since it is adjacent, we could say that 60 multiplied by cosine 30. The partner of adjacent is cosine. Likewise, the partner of opposite, Fy is opposite to the angle, so the partner of opposite side is sine. So you just multiply the magnitude 60 by cosine if you wanted to get for the horizontal component. This is called horizontal because parallel to the x-axis. This is called y component, Fy, because it is parallel to the y-axis. So you can get their magnitude by simply multiplying the magnitude with respect to particular trigonometric operation term. I think this is it. Now, let us try to apply the addition, the concept. Now let us have this example. Our objective in this example is to sum the forces. We wanted to sum 3 vector forces. Now what we are going to do using the component method, we are going to break this down into components. So what we are going to do, what is the component of 60? So let us draw the components of 60. And I'm gonna use, I think, gonna use this one. What are the components of 60? The components of 60 is this one. Let's draw this one. This is the components of 60. So this is just equals to, and also the component of 60 with respect to y. Okay, so the x component of 60 is 60 multiplied by what? Cosine 30. This one is opposite to the angle. So this is 60 sine 30. Okay, so we do the same thing. Let us use another color for this one. We can say for the 50 we can have the component of 50. So this is our 50, and the y component for the 54s, this is the y component. Okay, so we could say that this is with respect to the x-axis. So we can say that this is 50 and this is adjacent, the angle is 65. We will use cosine 65, and this one is opposite to the angle 65, so we would say 50 sine 65. And this one, we are not going to use this one with cosine and sine because we would consider this as y component. Okay, this 25 by itself is already a y component. As you can see, our components is always with respect to horizontal and also with respect to vertical. That is how we get components. We cannot get components that are inclined. Okay, so that is the important thing. Now another important thing that you need to understand, and this is a very important, is the sign convention. Sign convention. Our sign convention, if the component forces are pointing towards right, then the sign is positive. If it is pointing towards left, then the sign is negative. If the force is pointing upwards, then it is positive. Conversely, if it is pointing downwards, then it is negative. Now, how do we sum? The way to sum this is we are going to sum them by components. So we are going to sum the x component. This is summation of x component. We are going to sum all forces that are acting with respect to x-axis. What are the forces that are acting with respect to x-axis? Now, this is again an important thing that you need to consider. We are going to use the components. If I use the component of 60, we have 50, 60, and 25. If I use their components, then we are not going to use them anymore. So in other words, I'm going to use the components, therefore we are not going to use these forces anymore. So let us erase this one. So I'm going to erase the 60 because I will be using 60 the components. And also, okay, so the same also with 50. since I use the components, the x and the y, so we don't need to use 50. So we will just erase the 50. Okay, this is how you are going to understand the components. 25, we don't have any component. I said just a while ago that 25 is just a component of itself because it is parallel with respect to our major axis, the y and the x-axis. It's just acting parallel to the y, so we just let it stay. Now we have forces. Okay, we have forces that are components of the three forces. So we would sum the forces that are acting on x. What are the forces that are acting on x? I'm just going to erase this also. 30. Erase the 30, we erase the 35. This is how we're going to analyze this one. Now, what are the forces that are acting with respect to x? We have the 60 cosine 30 and also the 50 cosine 65. Now, we are going to see this one. 60 cosine 30 is acting to the right. So the sign convention is positive, so we're going to use positive 60 cosine 30. Okay? Now, while this one is pointing towards left. So what does the sign convention say? When the force is directing towards left or pointing towards left, then it is negative. So therefore, this force is negative 50 cosine 65. Now, are there any forces that are acting with respect to our x-axis? There are none. Only two, 60 and the 50. So we would sum these two. We would use our calculator. It's just equal to 60 cosine 30 minus 50 cosine 65. Okay, so the total force that are acting on our x-axis is 30.83 Newton. The same thing also, we are going to sum forces acting along y-axis. So how many forces acting along y? We have 1, we have 2, and we have 3. So according to the sign convention, when the force is acting upwards, then it is positive. Force is acting downwards, it is negative. Let us start with 60. 60 is acting upwards, therefore it is positive 60 sine 30. Then this one also is acting upwards, so therefore plus 50 sine 65. Then this force is acting downwards, the 25 acting downwards, therefore it should be negative according to the sign convention. So negative 25, no more multiplication, no more multiplier. Okay, so we just sum them. You just input this into your calculator. Plus 50 sine 65 minus 25. Then we have this value 50.31. Now let me ask the question. What is the objective of this problem? We wanted to sum the forces which are, let me bring back the forces. We wanted to sum the forces, this one and also this one. We wanted to sum the forces 60 Newton and this one is 50 Newton. I just bring them back. So what is the answer? The answer is like this. To get the sum of all the forces, it is called resultant or the total sum. It is represented by R. And how do we get the sum of the vectors, sum of the forces? It is represented by this formula. Let me just rewrite this again. Represented by this formula. The summation of forces along x squared plus the summation of y squared. So we just input the value summation of x. This is the value. So we just input the value summation of x. What is summation of x? 30.83. Just square it plus the summation of y, then square. The summation of y is this one, 50.31. You just square it. So what is the total value for r? And I'm going to repeat this once again, that the value of r is, that the meaning of r is the total or the sum of all the forces, or the sum of the vector quantities. Therefore, the sum of all the vector quantities, 50 and 60 and 25, is the value of this r, which is equivalent to 59 Newton. And I think this is for the component method. We're going to solve the resultant or the addition of these three forces using polygon method.